All right, here we're looking at section 11.3. And our learning targets for today, we're going to find areas of rhombuses and kites. Then we're going to find some angle measures in regular polygons. And then we're going to find areas of those regular polygons. So the first thing we want to look at is a rhombus and a kite. And remember, we've talked about these different types of quadrilaterals before. So a rhombus has all four sides are the same length, but the angles are not 90 degrees. So it's not a square, but the sides are the same length. When we're finding the areas and dealing with these, we're going to be looking at diagonals. And diagonals go from one corner to the opposite corner. Okay, so here's diagonal 1 in this rhombus and diagonal 2. So same thing with this kite. I have two diagonals. And remember, a kite has two sets of congruent side lengths, but they're not all congruent. So to find the area of both my rhombus and my kite is I take the first diagonal times the second diagonal and I divide it by 2. For both of these kinds of shapes. So now let's find these areas here. So first I see I have a rhombus because I'm given that all four sides are the same, and I'm given the lengths of both of my diagonals. So I go ahead and I use my area formula, which is 1/2 of the first diagonal times the second diagonal, and I plug in what I know. So I've got 1/2 times 6 times 8, which gives me 24. So the area here is 24 meters squared. So now let's look at this kite. And I see that it's a kite because I have two sets of congruent sides. And again, I'm given the lengths of my diagonals, which are 7 and 10. So again, I use my area formula, and I plug in my information, and I get that the area of this kite is 35 square centimeters. So try these first. I would always draw them out and see what you can get from there. So now we're going to be looking at some angle measurements in regular polygons. So remember that a regular polygon has all sides are the same length. So that's what we're looking at here. So here I still have my circle and my regular polygon inside my circle. So this P is the center of that circle, or it's also the center of my regular polygon. Okay, so here's some information. So the center of a regular polygon and the radius of a regular polygon are the center and the radius of its circumscribed circle. So again, my radius length is also dealing with the circle around it. Okay, so the distance from the center to any side of that regular polygon is called the apothem. Okay, that's the height of my isosceles triangle, right? And I'm always going to be breaking these polygons into isosceles triangles, so that apothem is the height of that triangle. And remember, to find the area of a triangle, I need to have that height value. Okay, so here's our first example with this. So in this diagram, ABCDE is a regular pentagon, which means all the sides are the same length, inscribed in circle F. Find each angle measure. So first I find the measure of angle AFB. So AFB, right? So first we always want to trace out what we're looking for and go from there. Okay, so I know that AFB is a central angle, right, because it comes from the center. So I take my entire circle and divide it by however many sides it would take, right? Because here's one angle. That's another one, another one, another one, and this fifth one. So since I have 5 sides, I divide that by 5, so I know that that angle is 72 degrees. So now I'm looking at the measure of AFG. So AFG, which is down right here. So FG is my apothem, right, because it's the height of this triangle. So it's the altitude. Okay, so I know that this angle is going to be cut in half to make my smaller angle. So it's going to be 1/2 of what I found for AFB. So my angle right there is going to be 36 degrees. So now I'm trying to find the measure of angle GAF. Well, here I have my triangle, right? So I've found this missing angle. I know that this is 90 degrees, so that leads me to be able to find that part. Okay, so the triangle sum theorem, I know that all of the angles in a triangle add up to 180. So I can plug in what I know and find that that missing angle was 54 degrees. Here are some that I want you to try, especially look down here, try and find these missing angles. So now we're looking at the area of this regular polygon, right? So this is our third learning target, is to find the area of this regular polygon. So my n-gon, n just tells me however many sides I have. So if it's a 6-gon, right, we know that as a hexagon. If there's 5 sides, that's a pentagon. And I know that each side length is s. Okay, so we're going to call each side length s, and here you see again my apothem. So here's how I can find that. So the area of a regular n-gon, so my regular polygon with side length s, is 1/2 the product of the apothem and the perimeter. So I'm going to have the perimeter of my entire thing and my apothem. So I can write this as either 1/2 A times P or 1/2 A times NS. And NS will find us the perimeter because I take the number of sides that I have and multiply it by the side length. So now let's try and find this one. So a regular nonagon, that tells me there's 9 sides, is inscribed in a circle with a radius of 4 units. Find the area of the nonagon. So the first thing I need to do is I need to find my central measure, and since I know it's a nonagon, there's 9 sides, so there's 40 degrees in this angle right here. My apothem bisects that central angle, so this KLM is 20 degrees. So now I want to use my trig ratios to find the measure of that apothem. Okay, so I know here that these are both 4, right? Because that was the radius of my circle. My angle measurement here was 20, and I know that these two are the same length. So now let's go ahead and set this up. So I know that the sine of 20 degrees equals MK divided by LK, right? So sine is opposite over hypotenuse. So now I can plug in what I know. So the sine of 20 degrees equals MK divided by 4. So I can just put this in my calculator and find that out. So I also know that the cosine of 20 degrees equals LM over LK, right? Because cosine is the adjacent side over the hypotenuse. So again, I can find those measurements. So a regular nonagon has my side length of S, which is 2 times MK, right? So MK was just half of one side length of my nonagon. So I end up with 2 times 4 times sine of 20, which is 8 times the sine of 20. And here's my apothem, which I found was 4 times the cosine of 20. So from there, I can plug in what I know and find the area is 1/2 times the apothem times the N, which is the number of sides, times S, which is my side length. So here I've got 1/2. Here was what I found using my trig values for the apothem. There are 9 sides, and I know that this is 1 side length. So now I can just plug all of this into my calculator, and I find that the area is approximately 46.3 square units. So now here's kind of a real-world example dealing with different polygons. So I'm decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon, so I know I have 8 sides with 15-inch sides, and a radius of about 19.6 inches. What is the area you are covering? So the first thing I want to do is I want to find the perimeter of my tabletop. And I know that each side is 15 inches, so I can just multiply that by 8, which gives me the perimeter of 120. So now I need to find the apothem. So the apothem is the height of PQR, right? And we're just going to look at this triangle, this isosceles triangle down here at the very bottom. So if I draw a line straight down, that's my apothem. Okay? So it bisects this center angle and it bisects this side length as well. So when I put this point here, I know that this from my center point of my apothem to Q is 7.5 inches. So here we've got a little picture drawn to show us what we're looking at. So I've got my 19.6 radius, and I know that this piece is 7.5 inches. So now using Pythagorean theorem, I can find my missing RS piece, right? So it's the square root of 19.6 squared minus 7.5 squared, which gives me approximately 18.108. So now I have my apothem and I also have my perimeter. So now I can find the area. So I use my area formula for a regular polygon and substitute the values that I found and simplify with my calculator. So the area that I'm covering is 1086.5 square inches. So now here are a few for you to try finding the area of these regular polygons. Definitely look at number 6 and see what you can do without being given much information. So back to our learning targets. First we looked at the areas of rhombuses and kites, and to find those areas we used the diagonals in both of those figures. Then I looked at some angle measures in regular polygons and how to find those. And then finally we used the apothem to find the area of a regular polygon. So now that we've looked through these learning targets, go ahead and work on your homework for 11.3.